Hi, this is Dane Quinn from the University of Akron, and today I'd like to give you a super short video lecture on acceleration, just kind of what it is, and that will be followed later by additional lectures on acceleration equations and how to calculate acceleration and that kind of thing. I want to start off with just a really quick description of what acceleration is. Well, you probably have seen this before, but it's the derivative of velocity, right? So here, if I have a point P that's moving along a path, then the vector from O to P is r, P with respect to O. And that's the position of P with respect to O, where O is fixed in the ground frame of reference, right? So here this frame of reference F represents the ground, or the directions I and J. So then the next thing we do, and we have a short lecture on this as well, is to calculate the velocity. Right? So the velocity here is actually the derivative of the position, right? So d dt r of p with respect to O. So again, we've already seen that. Now acceleration becomes, well, basically the derivative of that. So here, if I write the acceleration of p, it's going to be the derivative of the velocity of p. And of course, taking one step back, the velocity was the derivative of the position, d dt r of p with respect to O. So we see that the acceleration can be thought of as now the second derivative of position, p with respect to O. Now, going back to look at this picture, we can represent the acceleration as a vector. So I like to draw the acceleration vector coming from the velocity vector, because clearly, given this position P with respect to O, the velocity vector represents, of course, the change in the position, and then the acceleration represents the change in velocity, right? So here, this blue vector moves in the direction of this green vector, right, with some magnitude. And then the acceleration indicates that the green vector moves in the acceleration or in the direction of the pink vector with, again, some magnitude. So looking now, we have position, right? We have velocity, and we have acceleration. So if I want to move from one to another, right, I essentially use a derivative. Or the operation is of course, a differentiation. Right, so that's d dt. Right, so the derivative of position will give me velocity, and the derivative of velocity will give me acceleration. Likewise, if I wanted to move kind of in the other direction, well, that would be integration. Right, so that's the integral of whatever we're looking at. And that allows us to go from acceleration to velocity, and then velocity back down to position. So with these operations, we can move from position to velocity to acceleration, and then kind of back again. So that's it. It's just, again, as promised, a really quick introduction to what acceleration is. This, of course, will be followed by a longer video lecture that really uses this concept of acceleration to describe the acceleration equations for a mechanism and its kinematics, and ultimately to determine acceleration variables. So that's it. Hope this has been useful for you, and I will talk to you again. Bye.